page 36, number 6. This is, in my opinion, the toughest one that was assigned to you this week. And the question says, sand is being dumped on a pile in such a way that it always forms a cone whose base radius is always 3 times the height. So I'm going to make a note of that the radius is always 3 times the height. Therefore, I could say 1/3 r is equal to h. The function v, whose graph is sketched in the figure, gives the volume measured in cubic feet as this. V of t equals 1/3 pi r squared h. At what approximate rate is the radius changing? So what I'm looking for is the rate that the radius is changing. dr dt equals question mark. When, well, after 6 minutes. So when the time is 6 minutes. So this is a related rates problem, and I'm going to need to take this, and I'm going to need to take the derivative with respect to t. But I don't like that there are r's and h's in here. So the first thing that I'm going to do is rewrite my problem and get rid of the h right here. I'm going to replace it with 1/3 r. So v of t is equal to 1/3 pi r squared times 1/3 r, of which I'm going to simplify to 1/9 pi r cubed. So that's my new radius volume equation. And then I'm going to take the derivative with respect to t. So the derivative of v is dv dt. Here I'm going to do a power rule, so this becomes 1/3 pi r squared dr dt. And then I'm supposed to evaluate this at time is 6. So I have to see what can I plug in at time is 6. Well, really, I don't have any of this given information right now. I am trying to solve for dr dt, but I need to know what dv dt is, and I also need to know what r is. Let's first try to find dv dt. And that's going to require some work. dv dt is the derivative of v. This is the graph of v, and I'm supposed to be finding this at 6. So at 6, I'm trying to figure out what the derivative is here. To find that, I'm trying to estimate the slope right here. What I'm going to do, since I'm looking for the slope right here, I'm going to pick 2 points on either side and find the slope between those 2 points. I'm going to say y minus y, so this y is 5 pi, minus this y is maybe 3.4 pi, something like that, over x minus x, so 7 minus 5. Now, if I were to type that all into my calculator, I would get that my slope is 0.8 pi. Now, that's just an estimate because I estimated the 3.4. But in for dv dt, I'm going to put in 0.8 pi. 1/3 pi. I need to figure out what r is as well and square it. So I need to find r when time is 6. So that's the other thing I need to find. Well, I'm going to go into this volume function right here. And I know that that's the formula for the volume. And I need to figure out what r is at time is 6. Well, at time is 6, let's come up to our volume graph. And at time is 6, it looks like my volume is 4 pi. So I'll write my equation. My volume at time is 6 is 4 pi. 1/9 pi r cubed. And I'm going to just solve this equation for r. So I can slash the pi out from both sides. I can multiply both sides by 9. I can take the cube root of both sides, and I get that r is the cube root of 36. So that's going to go in right here. At this point, I'm going to turn to my calculator to help me with the rest. Into my calculator, I'm going to divide both sides by this 1/3 pi cube root of 36. And let me show you what I've got into my calculator here. Okay, into my calculator, I have 0.8 pi divided by 1/3 pi cube root of 36 squared. and I get 0.22. So 0.22 giving me the answer of A. That was the tough one. Okay, next up is page 35, number 5. And this time they tell you that y is equal to u plus 2e to the u. They tell us what u is, and they ask us to find the derivative of y. So before I can find the derivative of y, I'm going to plug in and figure out what y is. So I'm just going to go in, and wherever I see u, I'm going to plug in that value. So y equals 1 plus the natural log of x plus 2e raised to the 1 plus the natural log of x. And then so that's what y is, and now I'm going to take the derivative. So the derivative of y is y prime, or dy dx, equals 1 turns to 0. The derivative of natural log x is 1 over x. The derivative of e to anything is recopy it, times the derivative of the exponent. Well, the derivative of 1 is 0, and the derivative of natural log is 1 over x. Now I need to evaluate this at x equals 1 over e. So now I'm going to go in, and wherever I see x, I'm going to plug in 1 over e. So 1 over e is just e, plus 2e raised to the 1 plus the natural log of 1 over e, which I'm going to write as e to the negative 1, times 1 over e, which is just e. So here if I simplify, e plus 2e, up top here, this ln and this e can cancel out. So really I have 1 minus 1, or 0, times e. So I have e plus, e to the 0 power is just 1. So that's just 1. So e plus 2e, which is 3e, leaving me with answer choice C being my answer. Okay, next up I am on page 55, number 27, and this is a non-calculator problem. It says the particle moves along the coordinate plane so that x, its distance from the origin at time t is greater than or equal to 0, is given by this. So that's my position function. Question asks, when is the first time the particle is moving to the right? Well, when something is moving to the right, the velocity is positive. So I need to get to my velocity function, which means I need to take the derivative of this position. I'm actually going to rewrite this position as the cosine of t quantity cubed. And then when I take the derivative of it, it becomes the velocity. I need to do a chain rule. 3 to the front, cosine of t squared times the derivative of the inside, which is negative sine t. And to figure out when something's moving to the right or when the velocity is positive, I'm actually going to set the velocity equal to 0 first. And I'll figure out when the velocity is 0. Well, right now, I have two things multiplied together to equal 0. So to solve for t, I just said each term equal to 0. I'm asking myself, when does this equal 0? Or when does the cosine equal 0? And when does the sine equal 0? Well, if I think about my unit circle, the cosine is 0 at pi over 2 and down here at 3 pi over 2. The sine is 0 at 0, at pi, and at 2 pi. And I could keep going around and around forever, but glancing at my answers, they only go up to 2 pi, so I'll stop there. So that's when the velocity is 0. So I'm going to make a number line, and I'm going to put these values on there. 0, pi over 2, pi, 3 pi over 2, 2 pi. Keep in mind pi over 2, pi, 3 pi over 2, and 2 pi. Okay, and then I'm going to pick some test numbers. This is a velocity. Anything in between 0 and pi over 2 is in quadrant number 1. Anything, I could pick any angle in there. I'll just write quadrant 1. In between pi over 2 and pi is quadrant 2. In between pi and 3 pi over 2 is quadrant 3. And then over here between 3 pi over 2 and 2 pi, quadrant 4. So I'm trying to evaluate the velocity in those quadrants. So I'm going to go up to my velocity equation. And something nice happens. This cosine is squared. So no matter what t value I plug in, this is always going to be positive. So we really only need to focus on plugging it in right here. So if I plug something in quadrant 1 in, well, the sign in quadrant 1 is positive, because remember, all students take calculus. It's positive, but there's this negative in front, so it's going to create a negative. Quadrant 2. The sign in quadrant 2 is also positive, but there's a little negative in front, so it's negative. Let's move to quadrant 3. The sign in quadrant 3 is negative, but a negative times a negative is a positive. That was the first time that we saw the velocity being positive, and so the answer would be answer choice C. Okay, next one is page 122, number 16, and we're given a natural log of cosine 2x and asked to find the derivative. So f prime of x is the derivative. Well, the derivative of natural log is always 1 over the function. So 1 over cosine 2x. I have to do a chain rule. The derivative of cosine 2x is negative sine 2x, and there's another chain hidden in there, times 2. So now I have to match this up to the answer. My answers have tans and cotans in them. So first thing I would do is put a negative 2 out front. I have a sine 2x on the top, and a cosine 2x on the bottom. And then if you remember, sine divided by cosine is tangent. So negative 2 tan 2x would be my answer choice A.